Hello Titan Dev Team. Today we are going to be taking a look at optimizing our game world. Now, some of you might have noticed our performance has been dropping as we have been adding more and more content to our game world. That's not necessarily surprising because we've gone from a completely empty map, apart from our landscape, to something that's starting to get quite densely populated in areas. But at the same time, there's still some performance changes that we can make. So we want to start trying to tackle that now as we go, rather than hitting it all at the end, just to try and keep things a bit more manageable. Now, one of the ways that you can do this, or I like to do this, is just by starting out by making sure that we have both our stat FPS and stat unit to say our individual areas, so our game thread, our GPU and so on, so we can start to see where we're actually starting to struggle in certain areas. And we can have a bit of a fly around and start to look at content. But if we get a reasonable snapshot of our game world, so let's do something like this. And then we type in profile GPU into our command line. We get this graph. Now, this is really useful for very quickly identifying areas of cost. So you can see straight away, we already have a scene capture here called BP character render, which is causing a pretty significant render thread. Now this is basically our pause menu character renderer, and it's supposed to only be running when we pause the game. So if we go and find that asset, let's go character renderer, there we go, and let's open it up and take a look at how this has been set up. This has been set up by me, so I do know where we're going with this. But basically, we can go over here and we can take a look. Now, this is set to render every frame and capture on movement, which for a pause menu character, we don't need. We don't even need this to actually be rendered straight away. So we could actually just instantiate this into the world whenever we need it, or put it into a set data layer and make sure that it only loads in when we need it. So we're just going to turn that off, and then let's do another profile because this is a snapshot, so it's not an active profile. And you can see we've already got rid of that element. So now we can take a look at our actual frame budget. So these are all of our, this is basically our scene rendering cost, which you can see takes up the vast majority of what we need here. And if we open this up, we can see what each individual area is doing. Now, there tends to be very similar bottlenecks with pretty much everything that we're doing. Most of the time that is going to be shadowing, post-processing, volumetrics, lumen, things like that, which generally cause a cost. So we've got things like our temporal super resolution, our volumetric cloud view, and then we've got some slightly smaller elements, so direct lighting, lumen reflections, initializing physical pages, Lumen Screen Pro Gather. So Lumen is quite a big hitter for pretty much all of this stuff. But it does give us a bit of an indication of where the general costs are coming from so that we can start tackling those. And this can be really useful for this kind of stuff. So one of the areas that it's struggling with is both our volumetric clouds, but also our lighting as well. So we can start taking a look at some of those areas, maybe with Nanite, because we're paying for that cost, but it'll be good to have a look at those different areas as we go through. So these are really useful for identifying, kind of what's that high cost area and why is it causing us stuff. The next thing that we tend to look at is kind of just visually inspect the scene using some of our buffers and our previewers. So if we take a look at here, and you can kind of see that I start to notice like a bit of a performance drop when we fly around this forest. So I'm going to just take a quick look at this particular map when we go through. In addition to that, forests and foliage can tend to be some pretty big performance hitters if we're not careful. So it's important to have a look at those areas because they generally tend to be a bit of a performance hitter. Now we've got this asset that's been created here, and let's just take a look at that actual asset and see how it's been set up. So we can take a look at the collision for one. Not necessarily going to be something that's going to be affecting us from a rendering standpoint, but the more stuff that collides in the world and the more complex that collision is, that can tend to give us some issues when we're looking at it later on. So we can show our collision, and you can see that we've got some fairly that's a little bit janky going in there. It might be worth swapping these out for just some capsules around the core branches as we're going through. This is quite complex sets of collision. You can kind of see all of these different areas that are kind of coming in. That's going to cause quite a lot of problems. Now, they've done the right thing here and not put colliders on any of the actual kind of leaf elements, because you wouldn't really expect to collide with that. You'd expect to kind of go through it. But for these, it's probably better to just have, kind of a single capsule, maybe in the middle. We can just add a quick capsule collider here, rotate it around to get it to fit. And capsule collisions are really cheap. There's basically the second least complex shape to render as collision, because they're basically a sphere across a line. So they're quite cheap from that point of view. So if we put one in, kind of like around here, maybe extend it just down a little bit just in case, make sure it's actually hitting our tree a bit better. So if we could do, a couple of those on some of the really core branches, we're going to have slightly better performance on there. But that's still not too bad. So let's just take a look at that. We've got nanite enabled. That's good. Though I noticed that I think this looks like a masked material. So generally we want to try and cut out where possible if the shape is simplistic enough for us to do it. It's not too bad on this one, though this is a very square shape. So I'd imagine that it's going to give us some not particularly organic end results. We're using a texture here and we don't need it, so we can just disable that. That one doesn't really matter too much because it's a 1 pixel texture and it will almost certainly be loaded in somewhere else. But we've got our spec value. Let's take a look at our alpha channel. So we've got a mask inside our alpha, and that's the worst use case of an alpha channel, because our alpha has such a worse compression, which ends up with a much higher quality texture. Using it for something like a mask is really pointless. So really this needs to be going into the R, G or B channels based on what needs it. And then if we go down, have a look through, we've also got this all looks okay. Again, yeah, that needs to be moved. That's all fine. And then this setting here, shading model, it's set to subsurface. Now, subsurface is a really high cost shading profile. We have another shading profile here, which is intended for things that need to have a subsurface effect, but aren't kind of like something as high priority as something like a character. So for anything that's kind of in the game world that we're going to be rendering a lot of, we want to use the two-sided shading model for that. It's going to give us very similar subsurface results with all of that anyway. I also noticed that the subsurface tint is also grey. It might be worth putting in a little bit of colour into that just to do it, but I'll just change this to two-sided foliage for now and leave it as is, and the artist can come back in and make some tweaks for that later on. So there we go. You can see very little visual change there, but actually, it's going to be a much cheaper shading model to actually render there. So we want to do that where possible, and that should propagate across all of these trees as long as they are using the same texture and model, material, which it looks like they are. So we've got a bunch of assets here. I'm noticing a little bit of light blinkering around the sea a little bit. That tends to be an indicator sometimes that we've got a lot of some extra lighting going on here, and that's kind of causing Lumen to kind of overexpose some of the non-rendered areas. So another thing that we can look at is just see what our light setup is. Now we've got the base time of day lighting system in place, which is our time of day manager, and that's been carefully modulated so that we actually knock out one light as the other light becomes stronger. So our sunlight is our key light, and as that kind of gets towards sunset, we drop that intensity and increase the intensity of the other one. And you'll probably notice there's a bit of a warning on there where it says, oh, you've got two competing lights. But actually, what we want is the effect where as one gets dimmer than the other one gains prominence. And what that means is that we only get shadow direction from one light at a time. So in this instance, we kind of want that effect. So even though the warning's there, it's fine because we want that end result in this particular instance. So if we type in lights, we can see that there is a directional light that's been put into this area over here. So that directional light is going to be affecting the entire world and is not something that we want in. So we need to go into here and we can either delete this light, though it's more likely that they have put this in just so they could see what their scene looks like in a standalone level. And in that instance, you want to make sure that it's marked as is main world only. Now, if your level that you're working in is a partitioned level, then this will be enabled. If it's just a standalone level, this isn't enabled, but it is in this instance. So we can go in and we can save that and we can commit those changes. So let's just check out that actor. And now you should see that that light is no longer visible inside here. So you can see that even though we've got this selected, that light is no longer rendering into this scene. So that's going to help us a little bit as well on the performance side, because we don't have to worry about that anymore. So let's go through. The next thing that we can take a look at is our view modes for nanite. So if we go in, take a look at, let's just do triangles only, just so we can really see it. And you can see that even though there's quite a few bits that have been rendered as nanite, a lot of this stuff is marked as not. Now, nanite is a much faster rendering path than traditional geometry rendering. So basically the general consensus is that if it can be nanite, it should be. So if you can render it as nanite, then you should enable it on your assets. So if we look at stuff like this, and we're not going to be able to make a change to this because it's all checked out. A bit of a worrying level instance layout here. I hope they're planning on collapsing this content later, because this is quite a lot. Let's see if they've got the actual asset checked out, because we might be able to just go in and do a sneaky convert while they're not looking. No, they have got it checked out. Okay, never mind. But generally, stuff like this should be nanite. Let's take a look at this one. This floating island that's being worked on, with a very large book in it. It's a very big book. So if we go in, take a look. This thing is 3.8 million triangles. So that's quite a lot. And if we go in and have a look, you can see that there's nothing in our nanite view. So we know that this isn't nanite. We can confirm it if we just go here and we can see enable nanite support is off. So this should have nanite support on 100%, especially an asset of this size. It probably also shouldn't be a single asset either, but as this is, I'm assuming a block out, then, we'll let it slide, and I'm sure they will fix it later on. So this is going to take a little while to process, so I'm just going to pause it while it does that, and then we'll unpause once it's done. So that's now processing as nanite. If we go in, we can just confirm, just to make sure, sanity check ourselves if we need to. We can see that that's now nanite. And generally we should have nanite on pretty much everything. So let's just go in, we'll just let that save. So let's go back to our nanite view and have a look and see what else has been missed from this. So we've got some cubes here, but is that editor cubes? Yeah. So ideally, we don't tend to want to place too much stuff down that's using the engine content for this kind of stuff, especially with blockouts, because we can't really turn nanite on for that. I'm going to guess if we turn nanite on for this as well. Yeah, so none of these houses, and this is quite a lot of content now. So this is all stacking up. None of this content is, and it's all using the basic cube. for this particular actor. Now, the problem is that if I go in and make a change to say, hey, this should be nanite, that change is only going to work on my machine because that asset actually sits at the engine level rather than the project level. So what we probably are better off doing is finding all the assets that are using this cube and building like a dummy prefab that we can then replace later on. And then we can do what we want to it inside the project and use it how we like. But for some of these other assets, they shouldn't be using it. So this wall here, this very clearly isn't nanite. So let's just go in. And look, we've got a bunch of assets in here. So let's go and just select all of these. I won't do that one because that's already checked out. And we'll just go to nanite, enable. We'll just let that run. And I'm just going to check out all of those. Go, nanite, triangles. We've started to see a little bit more. Still a lot of content over here that's not nanite. So let's just go in. But I'm assuming those are our default cubes for that scene. Let's have a look at this stuff over here. Really need to get a shortcut key for going to nanite triangles visualization. So none of this is actually marked as nanite. So all of these rocks here that have been put in, if we go in, and those are all checked out, so we won't be able to edit those. But those need to be. How about this? New nanite. No. There we go. Let's have a look at that one. See if we can check that out. It does not want me to select that. Right. Okay, so let's just enable nanite. Check out some very odd shadowing going on there. Quite know why I can't select it. There we go. So anyway, the rule is, if it can be nanite, it should be nanite. So make sure you're enabling it on your assets. The next thing that we can look at is shadows. So let's go over to our virtual shadow maps and cached page. This is usually a really good indicator of content that is invalidating or causing an invalidation of some kind in an area. And you can see that we've got some blue areas over here. Now, blue's not as bad as red, and you can see that, you know, kind of as we move around the actual, we are getting some invalidation anyway around these edges where it's, you know, it's outside of the view frustum. But the way that this generally works is that we've got these cells that are, you know, they get swapped out for smaller and smaller ones as you get closer, just like a, you know, virtualized texture. And the bigger ones are in the distance, but they're kind of representative of the same, you know, kind of texel space. So we can see some blue areas over here, so that's a good area to kind of like start looking at. So if we go over to this scene here, we can see a bunch of trees. Again, trees are a big hitter on, you know, they can be a big hitter on performance for this area, so they're a good one to look at. And if we take a look at this, let's just edit this asset here and see what's going on. So usually this kind of invalidation gets caused by world position offset. So if we go in and type in world position, and we'll just select all of these assets, So here it's marked as multiple values, which means that this person has actually set world position offset invalidation distance on our asset. So basically all of the content that's going to cause invalidation through world position offset does get disabled on distance, which is what we want, because again, like that foliage movement is quite subtle. So as we get far away from it, you know, kind of a couple of thousand units, you're just not going to see it anymore. So causing the whole shadow to invalidate just from that subtle movement is kind of pointless. But we're still getting a blue outline. So let's just take a look. So okay. So here while they have put the disable distance, they've set the mobility to movable, which obviously as a tree, with, you know, very defined roots going into the ground, it's probably not going to be moving anywhere. So in that instance, what we need to do is just make sure that this is set to static for that asset. Same with the root as well. We can set that to static. And it's worth just checking these as well to make sure. So you can see the default state on these assets is all movable, and that means that all of the actors in it are going to be tagged as movable. So whenever we're spawning our static meshes into the world, we need to make sure that we're setting up the behavior correctly for those assets. So in this instance, we need to make sure that we're marking them as static. We need to be very careful about whether we do actually want them to be blocking or not, because while that makes sense for trees, we really don't need these little shrubs to be actually having collision enabled on them. So wherever that's being set, and this one does look like it's this is the bush, so really we should be having no collision on those assets. We can choose whether we want to actually cast shadows or not. That can be a big saver as well. For things that are really low to the ground, they often can just add to the volume of the ground, and they don't need to be in there. And then we can also set our world position offset distance on here as well. So let's just set it to 3000, same as they had set it for their tree. And we can do the same for all of these as well. So just making sure that this is static, no collision. Again, don't want to mess their asset up too much here if we do that, but I think we can do that. I haven't seen any trees yet. I'm assuming that's just double check. Yeah, that's their bush going on there. Movable, static, no collision, disable distance 3000. And they've already got one checked out, so I'll probably undo that change just for now, and they can do it themselves later on. Just trying to be a little helpful, but clearly that's not working. So we've got another PCG in here as well. So let's just go through and see how they've done this. They're not doing any other sampling, I don't think. And then they're doing spawn actor. And they've set that as a collection. Okay, I understand. So this, we can go in and take a look at it. So they've actually split by branch and leaves. So this is fine, but also a little bit unnecessary. If you're spawning two assets, as long as the pivot's correct, you can just use PCG to spawn, on both points. If you see what I mean. So for this one, we've got our spawned actors of our pine sapling, and Corsican. So for these, we could actually still use this. You just do it twice. So you basically just put it in like this, and then you set one to be if we just get rid of that. One's then the actual foliage element, and then the other is the trunk. And you're basically just duplicating those points there. So you don't actually need to establish a blueprint for this. And again, like adding a blueprint in can make this a bit trickier as well. So you're best off not doing it. So yeah, just make sure those set to static as well. We'll just check those out. So yeah, you can go and you can delete the spawn actor and just have them all done through the static mesh spawner. Just duplicate it as you go through. Let's see. They've got one checked out, so I'm not going to be able to invalidate all of this, but hopefully we can go in and we can save some of this out, and we'll leave the others for them to do themselves. And if we go back in to our virtual shadow map and our cache page, hopefully we've done enough that we can start to see a little bit less invalidation. So you can start to see there kind of in the we're getting slightly less. It's harder to do effectively at this point because well, we are causing it. So yeah, let's maybe try, where else have they done it? There's nothing over there. Maybe try these ones, see if they're checked out. This is the Corsican. Can I check this out? No, checked out. Well, I'm going to just make it writable just so we can see it, and then we'll undo it afterwards. Okay, there we go. Let's have a look and try it now. Page. So we will still see some blue on this because we're still setting up our disable distance on our asset. But what we should be seeing is we should be able to, it's not set on those. That's why. Inconsistency. Ugh, catches me out every time. Right, so now we can see that we've got our world position offset. So it turns blue when we get close enough because the actual trees are moving. And we do want that to happen because we want that tree shadow cast behavior to be on, kind of on the ground and around it. So we do want that, but we don't want it on distance. So basically on distance, it's just going to fall back to a static situation. So that's going to be much better. So now you can see that as that page gets bigger and bigger, we're not invalidating, kind of a larger and larger space as a result. So we end up with a better end view. So just keep that in mind as you're building. So I won't save that, and they can go in and do that later. So we've got the same over here, but I'm going to assume we've just got some more foliage elements. Oh, what is that? Okay, a little bit of cache shadow invalidation going on over there. These trees look okay. I think they're all marked as static anyway. So yeah, I'm not sure what's causing this. We'd have to do some investigating to find out why. But it'll be the same reasons. There'll be some stuff that's marked as movable when it should be static, or there's something that's using a world position offset that's not got a correct disable distance set on it as we go through. Now, one other thing that we can do, which is going to give us some better HLODs off in the distance, is actually just start to tell the HLOD builder what it should and shouldn't be, kind of using to contribute into the HLOD. So by default, everything will get put into the HLOD view, and the HLOD again is that kind of let's just unload some data. We'll unload the cliff top region because there's a lot of content in there. Are we already unloaded? No, we're definitely not. Okay, there we go. Let's just unload all of it. So you can see that this is kind of like our proxy view that is being generated here. So basically all of the assets that we add into the world will get contributed into this. So it's going to try and calculate a good proxy piece of geometry for all the assets that we have in our scene. And you can see it does a reasonably good job of that. Perfectly good enough for the distant assets that we're looking at here. Now, the downside to that is that it's including everything in, and there's quite a lot of assets that we don't necessarily need to be included into the HLOD. Especially as they're kind of so far away. So if we take a look at this, for example, you can see that a lot of this content gets kind of broken or doesn't quite work as effectively, and a lot of the small pieces especially, we're much better off just telling it to just ignore it because it's going to take extra processing time to try and figure out how to correctly collapse all of that geometry down. So if we go in, let's just load in a couple of these regions so we can see what it's done. So we have all of these assets here, but actually a lot of them we can probably just say just don't bother with a HLOD for it. And again, it does depend on how far away it is, and then also the distance that we're trying to render the geometry at. But for this kind of stuff, we can usually pretty safely say you don't need to worry about it. It's very easy for us to do that. We just go in and then we say just don't include the actor and don't include the component in the HLOD. So we can just save that out. Same with like stuff like this. It's going to be so small. We're looking at it from like this far away. And as soon as it gets that kind of like sub-pixel view, it's like a lot of the time it can be unnecessary to render. There's exceptions to this. Because when we look at our calculations, so our world settings for world partition, we can change this dynamically. So we can actually have the HLODs get generated at a reasonably close distance. So if I was, say, kind of, I don't know, here is a good example, right? We could technically have the HLOD be generated over here, right? And you can still see a lot of these mushrooms that have been placed. They're going to be still distinctly visible, but it doesn't take much for them to get far away for us to not see it, and actually our HLOD's generally going to go to that view first. So a lot of these assets we can go in and we can just say don't use HLOD. And it's a good idea when you're building your scene to try and figure out what stuff do I want to be visible at distance and what stuff do I not really care about. So yeah, just something to keep in mind as you're working through. So we've obviously still got a fair bit more to go with this. A lot of the things that I've applied, I've only applied in a few different areas. But you can already see that, we've started to get a reasonably decent amount of frames back as we're going. So we just need to make sure that we're staying vigilant with all of this content as we build it. As this world gets more and more populated and more assets get added in, we're going to be seeing these kind of performance hits hit us more and more. So it's absolutely vital that we stay on top of all of the content that we're building and making sure that everything is as optimized as it can be, while keeping to our high visual standard that we're aiming for. So hope that this was useful. Make sure if you have got content in your in the game world that you're optimizing it and making sure that it is all enabled and set correctly. Hope this was useful, and good luck, dev team.